So let's see the amorphous silicon PV cell. This one is the most advanced of thin film technologies. This one is the most advanced. Here we have efficiency 6%. Makes up about 30% of PV market, 13% of PV market. And if we see the advantage and disadvantage of this kind of silicon PV cell, which is amorphous, we have mature manufacturing technologies available. There's mature manufacturing technology that we can develop this kind of PV cells. But the thing that's really concerning is in 20 up to 40% lose in efficiency. This kind of thing is quite hard. Like if you lose initial 20 to 40% in efficiency, it's kind of hard for us. So these are the drawbacks for amorphous silicon PV cell. And the second one is polycrystalline PV cell. These are non-silicon based technology operating efficiency. This is about 6%. We don't use silicon here. Instead, we use cadmium telluride, which is CdTe representation. Unlike most other second and fourth material, CdTe exhibits direct band gap of 1.4 electron volt and high observation coefficient. So this kind of element has two good properties. First one, the band gap, which is quite excellent. This one is like how much electron is involved in moving, how much energy is involved, how much energy is moved, how much energy is moved in moving one electron. Let's say this one, we don't have one electron, we don't have 1 electron volt. So this means how much electron volt or how much energy is needed to move this 1 electron. This kind of it has a good property and also high observation coefficient. If we talk about the advantage and disadvantage, we don't have 6 to 9% of module efficiency and 6% laboratory efficiency. As you can see, this is laboratory, still in the lab, and we can say immature manufacturing process for this one. For this one, we were saying mature manufacturing process, but for polycrystalline PV cell, we don't have immature manufacturing process. So this are like to give you an introduction. So you don't have to expect to know everything. Just have an introduction here and go and continue with what you want to read. Okay, so here let's see. After this, what we're going to do is let's see solar panel or solar power system. What does it look like? Solar power system. So here we have the solar radiation, which is sun, and we don't have this solar panel. So mainly after solar panel we have charge controller. This one, this is for the battery pack. So if we have charge controller, there's a battery bank here. So in the DC, right here, we don't have DC panel board, and then we don't have LED DC load and also the CFL DC load. CFL means like a compact fluorescent lamp, and also we have the DC load, so we can power these things. The other thing is if we use inverter, we don't have DC power, right? We can convert this DC to AC. We can convert this DC to AC using inverter. So we don't have distribution board AC, obvious. So we can activate like fan, AC or LED TV. So this is like how the solar panel system works. This is all about how the solar panel system works. So next we have the general elements of what are the general elements of making a solar power system? What are the general elements of making, like this one is what are the general elements of making the solar power system? So the first one is solar panel, the second one is charge controller, inverter. We were talking about this, but like let's see what they look like. Solar panel, charge controller, inverter and battery.